Alright, so we have talked about similar figures versus congruent figures. Do you remember the difference? Similar figures versus congruent? Similar figures. Similar figures are the same shape, but not necessarily the same size, whereas congruent figures are exactly the same. Same shape, same size. Okay? So the pictures that we're going to be looking at today, the figures, one's going to be small and one's going to be big. Alright? Now, we have spent time talking about how the sides and the angles correspond to each other, how they match up to each other. But today what we're going to be doing is we're going to have missing side lengths that we're going to then find. Okay? Figure out what that side length is based on what the side length is in the smaller or larger shape. So you can actually use this process to measure things that would be really difficult to measure. For instance, if there is a tree in your front yard that's pretty tall, you couldn't just measure a tree with a ruler or a tape measure. It'd be really hard to measure a tree. However, what you could measure is you could measure your height and you could measure shadows on the ground. And by using that information, we could figure out how tall the tree is. And we'll do an example like that here once we get going. First, we're going to start with some easier shapes. So we're going to pretend like this is a volleyball court. And this is an Olympic-sized swimming pool. And the shape of these two, well, the court and the pool, they are similar, okay? The shapes are similar. We know the volleyball court is 9 meters this way, and it's 18 meters this way. The swimming pool, on the other hand, we know that it's 50 meters the longest way, but we do not know what it is on the shorter side. So if do we have any swimmers in here? So 50 meters is correct for the length of a pool, correct? Yeah. And that's important to them, because 50 meters tells them, like if they're swimming 200 meters, then that is down and back, so 50 times 4. I have to do that 4 times. So they think about that 50 meters a lot. Alright, so if these two things are similar to each other, how could we use this information that we know to figure out what is the missing side length of that swimming pool? Again, how could we figure out what the missing side length of the swimming pool is based on things that we might already know? Josh. Add the other side to 50. So I can make the other side say 50? Okay. How's that going to help me? Why? Where are you getting half from? I'm not disagreeing with you, Josh. Just keep going. I want more detail. Don't just tell me because it looks like it's half. How are we going to use what we know about the volleyball court to help us with figuring out the swimming pool? Alright, so do we see that if I think about my 9 and my 18, this side is twice the length of this side. 9 times 2 is 18. Yeah? So we could think, what times 2 is 25, couldn't we? Yes. And what we're really doing here is we're using a proportion. Okay? And we've talked about solving proportions before. So for instance, if I talked about my volleyball court on top, and I'm going to do my swimming pool on the bottom, the 9 in my volleyball court, the 9 side, matches up with what side in my swimming pool? Let me say that again. The 9 side in my volleyball court matches up with the X in my swimming pool. Very good. So when I make a ratio, the 9 and the X match up, correspond to each other. Okay? The ratio of the 9 and the X is going to be equal to the ratio of your other two sides. The 18 in the volleyball court corresponds with the 50 in the swimming pool. Okay, so notice I put a V up here to help me remember to put my volleyball courts measurements on top, and an S down here to help me remember to put my swimming pool on the bottom. That's important. We don't want swimming pool on bottom in this ratio and then swimming pool on top in the other ratio. That'll mess it up. So 9 and X match up, 18 and 50 match up. And then we've talked about how to solve proportions. This proportion is one of the more simple proportions where we really can just think, oh, well, I know that 9 times 2 is 18, so what times 2 is 50, and that would be your 25, right? What is the other way that we can solve proportions that are more complex? What is that called? Cross multiplying, cross products. And we'll have some for the other examples where we have to use cross products. All right, so any questions about this problem? Excellent. All right, let's look at another problem then. So in this one we have 2 triangles. Now I just drew them in there, and I know it's going to take you some time to draw them. And your drawing probably is not going to look fantastic, and that's okay. But what I do want you to try to do is make sure, I'm going to label this little triangle A, B, C. Make sure you label it the same way I am. And I'm also going to put the measurements of ABC on here. So make sure you're putting the measurements on the correct side, just like mine. So even though your drawing might not look good, your measurement could still be there. Our other triangle is going to be called JKL. And it has some measurements as well. So I'm going to pause for a second, and I'm going to give you a few seconds to write that down, okay? All right, what is also going to be given to you? So again, all this information is given to you already. What's also going to be given to you is that they're going to say that triangle ABC is similar to triangle JKL. You remember talking about this before the other day? And we said when we're talking about the angles that match up, that angle A matches up with angle J. So really, not looking at your picture sometimes is the good thing. Looking just at this is the most helpful. In that B matches up with K, and that L matches up with C. Okay? So that is really going to help us here. So I'm going to start with a side that I know. I know that AB, we'll highlight it. AB matches up with what side? JK. Okay, not joking, for real. Okay, AB and JK. So let's look at AB in our picture and look at JK in our picture. These will form a ratio. So let's put AB on top, 8. And let's put JK on the bottom, 28. And again, that made a ratio for us. Now I'm going to have this equal another ratio, and I want this ratio to have the X in it. So the X is for KL. So I'm going to make sure I put that on the bottom because that triangle has been on the bottom. So again, this is for KL. KL matches up with BC. KL matches up with BC. And BC is how long? 12. All right, so now we've made a proportion. So what we did, once again, just to kind of summarize, we found the corresponding sides. We chose 2 sides that we knew that corresponded, and then we chose the side that corresponded with the side we didn't know. And what we did was we made a proportion with that information. And we're going to solve now this proportion. Can we use the easy method to solve this proportion? Can we say 8 times what is 12? No. So we're going to use those cross products. We're going to do 8 times X, and we're going to do 12 times 28. Now you have a calculator, so that should not be a big deal. 28 times 12 is 336. And then how do you solve for x? Okay, so 336 divided by 8 gives you, anyone? 42. All right, so that is our missing side. So we found two sides that we knew, we made a ratio, and then we made a ratio with the side that we didn't know, and we solved the proportion. This is how you solve for those missing side lengths. So now let's talk about that problem that I kind of led into the lesson about the height of a tree, okay? So if the sun is shining in the sky, put a sun on your paper, and let's say you have a person, and we're not going to spend hours drawing today because I like to draw, but we have better things to do right now. Now you can measure the height of a person. We're going to make the height really easy. We're going to say this person is 5 feet tall. When the sun shines down on you from an angle, it makes a shadow. And you can measure that shadow that's on the ground. And the shadow for this person right now is 3.75 feet. Okay? The person is standing near a tree. Again, we're not going to spend tons of time drawing. And I don't know how tall the tree is, because it's very hard to measure. But the tree is also casting a shadow on the ground, and we could measure that shadow, because it's on the ground. And the tree's shadow is 15.5 feet. So we're going to figure out what the height of that tree is based on the information that is given to us. We're going to make a proportion. What this is called is indirect measurement. We're finding the measurement of the tree without actually measuring it. Okay? So we're going to put the human on top, and we're going to put the tree on bottom in our ratios. And we can talk about, first we'll talk about the height. We'll make a ratio for the height. And then we'll make a ratio for the shadow. Okay? So now we're just kind of filling in the blanks. The height of the human is 5 feet. The height of the tree is, we don't know. So what do we put in for a question mark? X or any other variable you want. Yes. The shadow of the human is 3.75, and the shadow of the tree is 15.5. So again, I'm saying this again because it's super important. If the person's on top, the person has to stay on top in both ratios. Trees on bottom in both ratios, or your proportion will not work. Alright, so now we're going to solve this proportion, and I know there's decimals, but we're allowed to use calculators, so it should not be a big deal. We're going to use our cross products. We're going to do 3.75 times x, and we're going to do 5 times 15.5. So 5 times 15.5 is 77.5. And we're going to divide that by 3.75. You're going to get a repeating decimal. Try again. 77.5 divided by 3.75. Right, your calculator probably says 20.6666666667. Why does it put a 7 on the end? Does it really mean that it stops? Alex. It rounded it. See, your calculator screen is only so big. So it said, oh, we're going to have to stop, so I'm just going to round that last digit. So it really is 20.6 repeating feet. That is how tall that tree is, without us actually trying to measure and climb up in it, how tall it is. Okay? Any questions about these? Let's do one more and then we'll be done then. Okay? In this last one, we're going to have some triangles. And Besides just finding the side lengths of the triangles, we're also going to talk about the angle measurements. Alright, so we can see two triangles. We have this big one, and the big one is going to be triangle ABC. And it's going to be a right angle. Angle B is going to be a right angle. And angle C is going to be 59 degrees. We're also going to know the side lengths. Now I'm going to jump over here to my smaller triangle. It is also a right triangle. It's just positioned differently. Again, this will be our last one for notes. They will tell you the information that triangle ABC is similar to triangle JGH. So I'm going to pause while you guys finish drawing that. So what do we remember about the angle measurements in similar shapes? So these shapes are obviously not the same size, but what about the angle measurements? Okay, the angle measurements in a similar shape are exactly the same. So do you see how B is 90 degrees? G is also 90 degrees. And look, B and G match up with each other. So C is 59 degrees. C is 59 degrees. What angle matches up with C? H. H is 59 degrees. So I'm going to go over here and I'm going to label angle H as being 59 degrees. So one angle is 59 degrees, one angle is 90 degrees, but I don't know what the third angle is. How can I figure out what the third angle is if it's not given to me in either of the triangles? Add the two angles that we know together, then what? What is the total of all three angles? 180. So what would we do with that information then? Good. So if we have 180, we're going to subtract from 180 the two angles that we know, which are the 90 degrees and the 59 degrees. So 180 minus 149, 31. So that means angle A is 31 degrees and angle J is 31 degrees. Alright, so now we know all three of our angle measurements, so we can move on away from that. So let's talk about our side lengths. Now our side lengths is where we use our proportion. Now I'm going to get rid of this work so I have space. So I'm going to choose two sides that correspond to each other. I'm going to go ahead and choose AB. What corresponds with AB? JG, yes. So AB is this. JG is this. So you can see how that could have been confusing if we didn't look at these letters down here. That helps us out a lot. So let's put AB on top and JG on bottom. AB is how long? 10. JG is 5. So there's our first ratio. Now in our second ratio, we want to make sure that we have the variable. So the variable is for which side? Where's the variable at? The variable. The side we don't know. Isn't the side we don't know right there? H, G, G, H, however we want to say it, doesn't matter. That corresponds with BC. Which one of those should go on top in my ratio? BC has to be on top. So BC is how long? 6. So 6 on top, and then HG or GH would be on bottom, so that would be our X. There we go. Good job. We have our proportion now. So we can solve for x. 10 times x, and then 5 times 6, you got it. So 5 times 6 is 30, so that means x must be 3. This side over here must be 3. So besides finding all the angle measurements, we were also able to find the missing side, okay, by using that proportion. Okay. That's how you did it. All right, so you're going to get your assignment now. Now, your assignment has 2 sides to it. Honestly, the back side is easier than the front side, so you may want to start with the back side of your paper. And on the back side of your paper, you're really not probably going to need to draw proportions because they're easy. You can see like, oh, I just need to multiply by 2, or oh, I just need to multiply by 4 to find that missing side, okay? The front side looks more like what we did in our notes, so hopefully you can refer back to your notes, and then I'll also get these posted to YouTube. And then I'll also be in here for you to ask me questions for the next 15 minutes.